Hello. Today we solve a question from SSSCE 1998, objective question number 1, and it reads that the sets A equals 2, 3 and B equals 2, 4 are subsets of the universal set U, which equals 1, 2, 3, 4. Find A complement union B complement, where A complement or A prime and B complement or B prime are, of course, they are complements of A and B respectively. Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing, click the like button so that the video can reach a lot of people. Thank you. Now let's continue. So first, let us try to understand what we mean by complement. But let me put down the set that we have here. The first set I'm going to put down is the universal set, of course, because all sets are subsets of the universal set, and that is 1, 2, 3, and 4. And of course, we have the set A. So I'll use the blue ink for the set A. The set A2 is 2, 3. And we have the set B. I'll use the red ink for the set B. So the set B2 we have 2, 4. Okay. So first, I want to talk about what we call complements before I proceed from here. Complements of a set. The complement of a set, say the complement of set A, refers to the set of elements in their universal sets that are not in the set A. I think we have to be able to differentiate between these two words. We have the word complement and this word complement here. We have E here, and we have another word we call complement here, and this one has an I here. So when we say complement, using this one, it's like giving praises. Somebody tells you, oh, my friend, you're very handsome, or your shirts or your attire is very beautiful, and so, oh, thanks for the compliment. You are talking about this one. But to compliment something is like to add to it to make it full, something like that. Of course, some people do say that women compliment men. So if we write A, then we are talking about a set A. So what is the set A? From what we have here, the set A comprises the elements 2, 3. You see, the set A is a subset of the universal set. So when we write A complement, essentially we are saying not the set A. That is the set A. So A complement means not in the set A. So in a set A, we have 2, 3. So what do you think will not be in a set A? Of course, we are told that the set A is a subset of the universal set. And when we say subset, it means it is within that set. So if we were to draw, say a Venn diagram to represent what we see in here, that is what we should have seen. Say if we were to draw a Venn diagram, we would have seen the set A. Let me use the blue color here. We would have seen the set A, something like this, and then the set B to of course, if you look at the A and B, we can see intersection. That is 2 and 2 here. So of course there will be an intersection here. So we see the sets B also here, and then you see the universal sets. That is the bigger set that entails the set A and B. So this is the universal set here. So if we were to put values of the elements of the set A and B into the Venn diagram, that is what we would see. For the set A, we have 2, 3, so we have something like this 2 here in a set A, but of course we see the 2 in A and B, so the best place is here. That is the intersection. Now we see 3 in set A, so we can put it here. We see 4 in set B, we can put it here. Now outside 3, 2, and 4, we have other sets that are neither in set A nor in set B. We see 1 here, so that is in the universal set. So that means they are not the element 1 is not in set A or set B, so we can put it somewhere here. Of course 2 is in A and B. We see 3 in A, and we do see 4 in B. So that is how it will look like. All right. So when we're talking about A complement, that we are talking about a set of elements that are not in A, but they are in the universal set. So that is the set A is 2, 3. A complement means what is not in A, that is not A. So it kind of means that what are the set of elements that complements the set A to make it a full universal set? What are the set of elements that add to the set A to make it the universal set? Now, if you look at the set A has 2, 3. So the universal set has 1, 2, 3, 4. The set of elements that add to the set A to make it the entire universal set, of course, will be the 1 and the 4. So A complement will be 1, 4. And of course, if you look at the set A here, you can see that the elements that are not in A are 1 and 4. So that is basically what we mean by complement. So when we say the complement of the set, we are talking about a set of elements that are in the universal set but not in that given set. So we have the set A to be 2, 3, and the set A complement means not A. So not A means the set of elements that are not in A. Of course, we see 2 and 3 in A. So those elements not in A are 1 and 4. So that is the first thing that we have here. And the set B has elements 2 and 4. So we want B complement. Of course, the question says we are to find A complement union the B complement. So of course, first we have to find our A complement. Then after that, we find the B complement before we can find the union of the two sets. So B complement, of course, we have the set B here, that is 2, 4. And if we are talking about B complement, it simply means not B, not the set B. The set B, we have 2, 4. So what is not in the set B? Of course, we don't see 1 here, and we don't see 3 here. So what are the set of elements that add to the set B, that complement the set B to get the universal set, that is the whole set? If I check correctly, I don't see 1 in B, so 1 is part of it, and I don't see 3 here, so 3 is part of it. So now I have A complement and I have B complement. The question now says I am to find A complement union the B complement. So when we talk about union, it's very simple. Union of a set means bringing them together, like just as we have a union, that is a group of people coming together, to form some sort of a group, from the word unite, to unite. So the union of two sets simply means bringing the two sets together. So of course, if we talk about A complement union B complements, it means we are bringing these two sets together. So of course, bringing them together, we have 1 here, 1 here. There is a repetition, so that means there is an intersection here. We write it once, so we have 1 here. And then in numerical order, we have 3 and we add 4. So that is the sets of A complement union the B complement. And if you look at the options that we have here, of course, we have A as the correct option, 1, 3, 4. So that is one way that you can solve this. And this to me quite looks a little bit longer. There is another way that we can solve this by applying what we call the De Morgan's law, and there is very quick. The reason why I love this is that the question gave us two sets A and B, and the question was asking us to find A complement union B complement. That is to say, we were to find two different sets. A complement wasn't given to us, B complement wasn't given to us. We were given A and B. So to answer the question, we have to find two different sets. I don't want to do that. This A complement union B complement is the same as A, intersection B or complement. That is what we call the De Morgan's law. That is the union of the complement of two sets is equal to the complement of the intersection of the two sets. Let us try to understand this here. We can embrace this in this interesting fashion. Like when we take the right hand side, something like this: A intersection B complement. Let us assume that we are expanding this. Of course we see brackets, so just as if we were expanding something like A intersection B, squared, something like this, you write A squared, something like that. So if we are expanding this, we will have, this sign will affect the A, so we have the A complement. And when this sign affects the intersection, it changes it to union. All right, and when this affects that, then we have the B complement this way. So that is how it looks. In the same vein, if I have something like this, A complement union B complement, I can decide to, in a way, should I say, factorize it out, something like that. So I can bring out the complement. The moment I bring out the complement, it will be left with A here. Now bringing out the complement will also affect the union, turning it into intersection. Then I have B here. So that is what we call De Morgan's law. Okay, so why am I using the De Morgan's law? I'm using the De Morgan's law because I can see that the question gave me the set A and the set B. The question asked me to find A complement union B complement. I do not want to find two new sets. No, I don't want to do that. I just want to use the sets that were given to me. So that is what I'm going to do. I know A intersection B, and it's very simple. There is set A, the set of elements in A and in B. That is A intersection B. So if I look at the set A, I see 2 here. And if I look at the set B, I see the same 2 here. So A intersection B, first A intersection B is 2. So if I am to find A intersection B complement, then it means the set of elements that are not in A intersection B, but they are in the universal set, which elements? So only 2 A's in the A intersection B. So those that are not in A intersection B are 1, 3, and 4. And that is the correct answer, just as we had here, 1, 3, and 4. So using De Morgan's law, there is no need to find, these 2 different sets, that is the A complement and the B complement, before you find the union of it. So, this is a very tricky way that you can, solve this question quickly than finding 2 new sets before you find the union of it. And, the sad thing is that most students may not even understand what we mean by complement. So that is how we do it. All right.